Hello guys, welcome back to our channel. So Shomu sir, what are we discussing today?
We're actually discussing a very basic problem.
Okay.
It's something to do with average speed. I mean, at the very end, the question that is asked for is a little different. It might not look at as average speed question, but it is actually an average speed question. So let me just jump into the question, Harsha.
Yeah, sure.
Okay, so we have, it starts with one can use three different transports, fair enough, which move at 10, 20, 30. So there are three different modes of travel, right? So there are three different modes of travel available to us, traveling at the speed of 10, 20, and 30 km per hour respectively. Now it says to reach from A to B, whatever certain distance, Amal took each mode of transport 1/3 of his total journey time. So
Okay.
it is using this speed, and this speed, each of them for 1/3 of the total time.
Right.
While Bimal took each mode of transport 1/3 of the total distance. So Bimal is also using each of the mode of transport, but in this case, 1/3 of the total distance.
Correct.
So we're looking for the percentage by which Bimal's travel time exceeded Amal's travel time. So if you look at the question, it doesn't talk about average speed in itself, right? But
Right.
But if you are aware of the average speed ideas, when you read the second sentence, to reach from A to B, Amal took each mode of transport 1/3 of his total journey time. So since the relationship between the times are given in the travel, and we know the specific speeds for each of the segments, then we can actually calculate the average speed of Amal, right?
Right.
Using that idea. And
Correct.
similarly, Bimal, in case of Bimal, there are three segments. Each segment, we have a relationship of the distances, and also we know the actual speed. So we can calculate the average speed of Bimal as well.
Correct.
So if I know the average speed of Amal, and if I know the average speed of Bimal, then I can figure out the speed ratio of Amal and
Right.
Bimal for the entire journey. And if I know the speed ratio, I can figure out the time ratio.
Correct.
And if I can figure out the time ratio, I can figure out the answer. So this process mapping should happen in our mind while we are reading this, right? If you understand this, then all you have to do now is apply the process and figure out the answer. So let's go ahead and do that.
Yes.
Okay. So what do we have? So let's start with Amal's case. Now, in case of Amal, we know that he travels 1/3 of his journey time for each segment, right? So there are three segments having speeds 10, 20, and 30. The time of each of the segment is equal.
Okay.
Now, when a relationship between time is provided, see, what do we need to figure out in case of average speed? Average speed, what is the basic idea of average speed? It is total distance by total time, right?
Total time. Right.
So if I have the relationship between the times of the three segments, I can assume a certain time which satisfies the relation, whatever the relation is. And for each of those times, using the speed, I can calculate the distances, corresponding distances for each of those segments accordingly, isn't it?
Right. Right.
So if I figure out the total time corresponding to the total distance, or the other way around, I can figure out the average speed using that idea, right? So here what we are going to do, we have a relationship between the time. So we are going to assume the time to be something for each of the segments. Then we are multiplying speed for each of the segment to figure out the distance of each of the segment, right? Something like this.
Right.
Isn't it?
Correct.
So in this case, if you observe, we are multiplying time with speed to get the distance, right? So if you are multiplying time to speed to get the distance, it really doesn't matter what we assume the time to be for each of the segment. So I'm just going to assume that the time for each of the segment is 1 hour, 1 hour, and 1 hour, as simple as that. So if I have the first segment traveled with a speed of 10 km per hour, that gives me a distance of 10 kilometers.
Right.
Second, 20 km per hour, 20 kilometers, 30 kilometers per hour,
30 kilometers.
So what is the total time that he travels for? 3 hours. Total distance covered, 60 kilometers. So the average speed is 60 by 3, that is 20 km per hour for Amal.
Right.
Now, if you understand this idea, you don't have to explicitly do all of this. You should be able to understand that what is happening here is simple average of 10, 20, 30. So if the time are equal, it automatically comes out to be the average, simple average of the of whatever speeds we have. But the time has to be equal. If that is not equal, then just assume the times to maintain whatever relation has been given. So for example, if this would have said that the first segment, the second segment, and the third segment, the time taken to travel are in the ratio 1:2:3, then just assume the times to be 1 hour, 2 hour, 3 hour, and do the same process, you will get the answer. I mean, the average speed rather.
Right.
Fair enough?
Correct.
Okay, so let's do this for Bimal. Now, here's a small difference here. So in case of Bimal, the relationship that has been provided to us is in terms of distances, right?
Right.
Again, we have the speeds. I mean, in both the cases, we have the speed, right? In average speed questions, I always need to have the actual speeds. I mean, the relationship of speeds is not enough. So the actual speeds will always be given in these kind of problems. So in this case, what are we going to do? We are going to have the distances assumed to be something. From there, using the respective speed, we are going to calculate the time for those segments, isn't it?
Right.
But from distance and speed, how do we get time? It is distance divided by speed equal to time, right?
Right.
So in this case, what I'm going to do is, see, for each of the segment, the distances are equal, right? So I just want to keep the calculation as simple as possible. So in order to do that, what I'm going to do is I'm going to assume integer values. I'm going to assume the distances to be something which leads to the time as integer values. So for instance, I need to divide the distances by what numbers? The speeds are what numbers? 10, 20, and 30, right? So if I assume the distance to be 60, then 60 by 10, 60 by 20, and 60 by 30, each of these will be integers, my bad. Yes?
3, 2, right.
So now what do we have? The total distance is 180 kilometers. And the total time is 11 hours.
11.
So we have 180 by 11 kilometer per hour.
Right.
Now, a couple of things to take a note of. See, we know that A to B both are traveling, right? In this case, we are getting the total distance as 60 kilometers. In this case, we are getting 180 kilometers. But that really doesn't make any difference because we are concerned about the average speed, right? For both of these people. So these are just assumed values. Nothing out here is actually the true value, right? So for instance, in 1 hour, if I consider T hours, so here I have 10T, 20T, 30T, something like this, right? And this becomes 60T. Here, if I take the distances instead of 60, 60, 60, if I consider 60D, 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 then I get these also in terms of D, something like that, right? But those D's and T's will cancel out in the calculation. So this is something which instinctively you should be able to understand that actual distance really doesn't make any difference in this problem. All we are concerned about are the average speeds. So now we have that with us, right? So let us quickly calculate the ratio of speed. So remember, we have to calculate a relationship between the travel times, right? Not the actual traveling time, but a relationship between the traveling time. So if I consider, so the speeds out here are 20 and 180 by 11, right?
Right.
So I'm just going to take a ratio out here. So I'm going to multiply this 11 here and cancel out the 0. Or rather, let's cancel out 20. That simplifies the problem further, right? So we get something like 11:9. Right. So this is the ratio of speeds, right?
Speeds. Correct.
So the ratio of time should be inverted. That is 9:11. So what are we looking for? We are looking for how much does this exceed this, right? Something like this. So from 9 to 11, what is the percentage increase? Something like that. Percentage by which Bimal's time exceeds Amal's time. So Amal's time is the base value. So from there, Bimal's time, how much percentage more? So that is what? 2 by 9? Right. So 2 by 9 is 22.22%.
22.22.
We're looking for an approximate nearest to. So that is option
A. Okay. Interesting one.
Yeah. So basically an average speed problem, it has been disguised as a time relation problem, but it's actually an average speed problem, right? You calculate the average speed of Amal and Bimal. From there, you get the ratio of speeds of Amal and Bimal. From there, you can figure out the ratio of time of Amal and Bimal, and that's it. The ratio of time is sufficient to figure out the percentage change.
Correct.
So that's it.
Thank you. Thank you so much, sir, for this wonderful question.
Thank you, Ashal. Thank you, everybody.
Thanks, everyone. Thanks for joining in.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.